Hello everyone. Now we are going to have a small introduction about optical communication system. Firstly, we start with the motivation for optical communication network. There are three primary needs identified. They are as follows. There is a demand for more bandwidth nowadays. Next, there is a high complexity and cost for electro-optical systems. And then there is a electronic bitrate bottleneck in the current systems. Next, let's see about history of optical communication. The history starts from 1876 when Elisha Gray and Alexander Graham Bell invented telephone. Next comes the invention of photophone by Alexander Graham Bell in 1880. The fiber technology came into practice only during the start of the 20th century. Next comes the fiber with cladding structure, which is shown in the picture given. And this is the current form of fiber structure. Here we have core, cladding, buffer, and an outer jacket. This was developed in 1954 by Van Heel, Hopkins, and Capani. Cladding is a glass or plastic cover around the core. It protects the total reflection surface contamination and it reduces crosstalk from fibers in bundles. Optical fiber is a glass or plastic fiber that carries light along its length. Light is kept in the core of the optical fiber by the phenomena called total internal reflection. There are a number of advantages for optical fiber. Optical fibers are thinner, they are less expensive, and the most prominent advantage is its higher information carrying capacity. And another advantage is about less signal degradation. And then the signal is in the form of light, and so your information will be more secured, and it is non-inflammable, and it is lightweight. Then advantages of optical communication. There is a much higher bandwidth in terms of gigabits per second to terabits per second because thousands of channels can be multiplexed together over one strand of fiber. Then immunity to noise. We can have immunity to electromagnetic interference in fiber. Then there is more safety in optical communication system because it doesn't transmit electrical signals, making it safe in environments like a gas pipeline. Here we have more security, and so it is impossible to tap information. Other advantages are less loss because repeaters can be spaced 75 miles apart and fibers can be made to have only 0.2 dB per kilometer of attenuation. And then fiber optics are having more reliability and so more resilient than copper in extreme environmental conditions. And its size is lighter and more compact than copper. It has more flexibility. Unlike impure brittle glass, fiber is physically very flexible. Then we are going to see about evolution of light wave systems. There are 4 generations in evolution of light wave systems. In first generation of light wave systems, there is a development of low loss fibers and semiconductor lasers in 1970s. Gallium arsenide laser operates at a wavelength of 0.8 micrometer. The optical communication systems allowed a bitrate of 45 megabits per second and a repeater spacing of 10 km. Next comes the second generation of light wave systems. Now, the attenuation of optical fiber drops from 2 to 3 dB per kilometer at 0.8 micrometer down to 0.4 dB per kilometer at 1.3 micrometer. The transition from 0.8 micrometer to 1.3 micrometer leads to the second generation of light wave systems. The repeater spacing could be increased by operating the light wave system at 1.3 micrometer. The bitrate distance product can be further increased by using single mode fibers instead of multi-mode fibers. Single mode fibers have a distinctly lower dispersion than multi-mode fibers. Then next comes third generation of light wave systems. Silica fibers have an absolute minima at 1.55 micrometer. The attenuation of a fiber is reduced to 0.2 dB per kilometer. Dispersion at wavelength of 1.55 micrometer complicates the realization of light wave systems. A bitrate of 4 gigabits per second over a distance of 100 km was transmitted in the mid-1980s. Then fourth generation of light wave systems. The development of the optical amplifier led to the fourth generation of optical communication systems. By using optical amplifiers, we can have optical signal with optical amplification, so no more electro-optical conversion, and so information carrying capacity could be improved, and then repeaterless distance can be enormously increased. So the major breakthrough in the evolution of light wave system is optical amplifier, especially EDFA, refers to erbium doped fiber amplifier. Then comes the elements of fiber optic link. A simple point-to-point fiber optic link consists of transmitter, which includes a drive circuit and light source, which is of either light emitting diode or laser diode. Then we have optical fiber to carry optical signal. Then we have regenerators or repeaters. Generally, regenerators are having double conversion, first to convert optical signal to electrical signal, and then to again converting electrical signal to optical signal. Then we have fiber to carry optical signal. Then at the end we have receiver, which is used to convert optical signal into electrical signal by using photodetector, amplifier, and signal restorer circuits. Elements of fiber optic link. The fiber is used to carry the light may be of single mode fiber, multi-mode fiber, or step index or graded index fiber. Single mode fiber has only one electromagnetic mode, and so it offers highest bit rate and it is most widely used nowadays. Multi-mode fiber is having multiple electromagnetic modes, and so higher dispersion we will have at the end, but it will be cheaper than single mode fiber. So it is used in local area networks and short range communication systems. Step index fiber is having two distinct refractive indices, but graded index fiber is having gradual change in refractive index structure, and they are having its own applications. Then optical transmitter converts the electrical information to optical format. Light emitting diode is cheap, robust, and it is used with multimode fiber in short range applications. Laser diode is a high performance optical source. It has more power and it is used with single mode fiber in high speed links. popular example of laser diode are distributed feedback laser and Fabry-Perot lasers. Then optical receiver at the destination end is used to convert the optical signal into appropriate electrical format. There are two optical detectors are used. They are pin photodiode and avalanche photodiode. Pin photodiode is having low performance and it has no internal gain, and it is very low cost and it is widely used. Avalanche photodiode has high performance with internal gain, which is always called as avalanche gain. So it is used in long distance communication. Repeaters are introduced when the signal gets attenuated highly. It receives weak light signal, then it amplifies and then retransmits. So it does double conversion, first from optical to electrical, electrically amplification, then electrical to optical conversion back. Then optical amplifier is used to amplify light signal in fiber without this double conversion. Thank you.